started. We will record the audio as well. Okay. Started the audio. Started the recording. Okay. So guys, today we will discuss about RNN. Hope I am audible to all. Okay. So RNN. So what is RNN? So RNN is a recurrent neural network. What is this? RNN is recurrent neural network. So what is this recurrent neural network? So recurrent, it is appearing again and again, recurrent, so many times. So you are not going to consider the output based on simple one, because you see you have a Go model already in NLP. See, look at this. In NLP, what is this? In NLP, we have come across bag of words. We have come across count vectorization, so right. We have come across TF, IDF. Means theoretically you know what is that. So this is happening based on only, for example, if you take one sentence. So if you take one sentence, so based on that sentence only it is trying to vectorize. For example, let us say you have word 1, you have word 2, right? You have word 3, right? So word 4. So you have sentence here, sentence 1, right? So sentence 1. So what is happening here? So whatever the word, for example, I am speaking about the dog. So dog is appearing, first word. Dog is running. So this is the running fast. You are looking for the dog. So the word 1, it is in word 1. So this is 0, 0, 0. If you are, so similarly, if you are looking for is, so it is here. If you are looking for what is this? Same sentence 1. So in the same sentence, what is this? In the same sentence 1. Okay. So in the same sentence 1. So for example, the dog is running here. I have given this dog is running. So here, in this here it is not there. So if you are looking for is word, it is like this. So for example, you have 4 sentences, right? So dog is running. I am dog. Okay. You are dog. You are dog. I am dog. Dog is running. What is this? Where is dog? So here this is sentence. This is sentence number 1. This is sentence number 2. This is sentence number 3. Sentence number 1, dog is running. Dog appearing is in the first word. Sentence number 2, I am dog. So dog is appearing in the third word, right? So similarly, sentence number 3, you are dog. So here also 0, 0, 1, 0. So fourth word is not at all there. Fourth word is not at all. This is sentence number 2. This is sentence number 3. So means like this we are representing them in the vectors. Vector, right? So what you have to do, these vectors are obviously it is going to be plotted. We are going to tilt it and plot it, and based upon that we are giving some, we calculate the count vectorizer, or we calculate the frequency, term frequency. Relatively we are going to assign some rates. So how much, if the two words, if you are comparing this with some other word, so we are going to give some weightage. So in that is in TF-IDF. So here, now what we want to do, see here what we are doing, we are giving the weightage. So if it is present or not, that is 1. If it is not, 0. We are not bothered about the context. See, there is no feedback system, right? There is no feedback system should be there, because in back propagation, what is the architecture? If you understand the architecture of the neural network, there is a back propagation everywhere. Everywhere there is a back propagation. How in back propagation what happens? What happens in the back propagation? For example, so this is the neural network. So this is the input. So what is the input? X1 multiplied by the weights W1. So it will pass on through the function, activation function. So what you will get? You will get y hat. What is y hat? Output. So output you are going to. So y hat is equal to, what is this? X1 W1 plus bias, right? So this is the in general. So this we are going to compare with actual output y. So y minus y hat, this is loss. So in order to minimize the loss, what we do, this W1, whatever the W1 it is there, that we will update. That is the normal architecture of any neural network. So now what I can do here? So here, in case of RNN, because what is this? In RNN, what happens? Each word is dependent on the previous word. Whatever the sentence you are going to say, you in general you speak. So there is a correlation between each word and the previous word and the next previous word. Why? Because then only that it is related. So right. So we want to establish the relationship there. So if you see the architecture of the neural network, now let us say, I will write it like this. See, understand the diagram completely. Understand the diagram. So you have like this. I'm going to write it like this. What is this? So this I will call first layer, right? So I will call this as first layer. These are the neurons or the nodes that are present at a time t is equal to 1. So what is the input? I am going to consider the input x I of 1, x or x11, I is equal to 1. At time t is equal to 1, I is equal to 1. So the whatever the weight that is there, I will call it as w dash. So you will get the output from the first layer. This is the first layer. So from the output of the first layer, so it will come. So output what it is coming, that is I will call it as O1. What I will call? I will call this as a O1, and this is a intermediate layers. Several intermediate layers will be there. Here also, what is the input? So x2, right? x2. So this is W1 is W dash. Here I will call it, coming from the first layer, I will call it as W1. So initially W dash, coming output from the first layer is W1. So W1 into O1. So at the time t is equal to 2. Similarly, so what is there? Let us say, let's consider 4 layers like this. So this is x3, right? So x3, so this is x3w, x2w, x2w. So this x1 is multiplied by this w plus what is this O1 w1. So that will be the output of port. So this is, I will call it as w dash. Similarly, so one more layer, 4 layers are considered, 4 intermediate layers. So this is x4w. So what I want to see, this is third layer, right? So the output coming from third layer is O3 multiplied by the w. Simply w1 w dash I am considering the alternative, right? So I'll consider this output coming is O3. Yeah, 4 everywhere. Simply you can decide that. Anyhow, we have considered 4. So now what is the output? W dash. So this is going to be passed through the final what is that output? Final activation function. So maybe I will tell you the softmax. What is how softmax will work? I will tell you now. Okay, don't worry. Softmax activation function. The final whatever is y hat. What is this final? This is y hat. And what I am going to see, so this is x I to I means 1 2 1 3 x 1 4 x 1 2 x 1 3 x 1 4. So at time t is equal to 3, time t is equal to 4. For first epoch, at time t is equal to 1, at time t is equal to 2, time t is equal to 3. So similarly for the second iteration, time t is x21, x22, xt3, xt4, like that. So it is like this. So what is this? So now if you are using NLP, see, don't think that NLP, if you learn, maybe today you think that NLP is so vast, so many things are there, but it will be useful everywhere. The applications are there, somewhere it will be. So NLP, for example, if you are using the sentiment analysis, right? So in sentiment analysis, so what I have to do, I have to find out the output of each this thing. So let us say, what is this O1? What is this? Output of the first layer. So what I can write? Output of the first layer, O1. So I can write like this. So what is this? Output. If output is coming means it has to pass through some activation function. If the activation function, that is only going to decide the output. This softmax is also activation function. But in each layers also there is an activation function. That is how each neural network works. So everywhere there is a activation function. Activation function. So it has to pass through the activation function. So what is the input here? X 1 1. What is the input? X x 1 1 into this x into w. X into w. That is the input. X is a parameter, input parameter, that is passed to the activation function to activate the particular activation function to get the output. So x1 w1 plus what is this? So external factor I am adding as bias, I am adding as w. Or will, as of now, let us say, see here, what is this? O1 w1 is the output from output layer 1, that is become input to output layer 2. So O2 W2 is output from input layer 2, that will become output layer 2, it will become input to input to layer 3. Similarly, I can assume dummy input O not. Can I assume or not? Dummy input, let us say 1, it is not going to affect. So dummy input O naught, so what I am going to write? So just like here, O naught into W dash. What is this? The so activation function. So x1 into W plus dummy input O naught into W is the input to the layer number 1. What is this layer number 1 output? O1. Got it? Any doubts you have? Right? Activation, I am passing the input into the activation function. So similarly,
similar to
A, huh?
it is similar to A.
A. One thing is there, means here what will happen, I will tell you what is happening in RNN. Some minor differences are there. So here also function, what is this O2? What is the input? X1 to W plus O1 W. Similarly, O3 is equal to activation function of X13 W plus O2 W dash. O4, output of 4 is equal to activation function. When you pass, what is that? O4 is equal to, we are going to output of the O4 is X14 W plus O3 W. Right? So like this. What is that? So this is the sequence. Sequential information is always maintained. In case of AC, ANN also same. AN is not going to work for the this data. Text data it will not work. So we are discussing RNN. ANN is not, see, ANN It's not good because you have 100 rows in ANN. Let us assume 100 rows are there in ANN. So, so network problem. Okay. Guys, you can see, right? You can hear, right? Hey, answer me.
Yes, sir.
Okay. So we will come back to where we were. See, here also, so output O1, O2, O3, you got it. So for example, what I was telling, in ANN, for example, let us say you had 100 rows, all are numerical values. See, the output you got from the...
Sir, presentation is not available, sir.
Okay, the output you got, fine. So now I think it's fine, right? So it's available.
Yes, sir.
Yeah. So in ANN, the rows you had, 100 rows you had. First output you got something. First row, what it is taking? It is taking the values from each values in that particular row. Second row, it is taking the values from second row only. The output of the second row is not dependent on the input of the first output of the first row. That is not sequential. Right? That is ANN. But here in RNN, what is happening? It is a sequential. So what you are going to conclude, the judgment whatever you are going to take, that is going to be based upon the sequence of the things that has happened precedent, the previous incidents that have happened previously. However you are going to vote today, that's going to be, you are going to judge based on the 10 years performance, 5 years performance, right? So that is RNN. So that is why we need back propagation here. So here what we want that is sequential things we need to, sequence information is always maintained. So that is why, look at this here, you look at the architecture of RNN, output O1 is dependent on the previous O dash, O0. Output O2 is dependent on here, output O1. Output O3 is dependent upon output O2. This is not the case in ANN. In RNN, it is always you have to consider the previous output for the next taking the next step. So that is the architecture of RNN. So RNN means the logic you understood, right? So that is what I wanted you to understand. So initial weights, whatever we are giving 0, this we will initialize. Dummy weights we will initialize, and that is. So another concept called as back propagation. So the back propagation. So now what is this? Finally, output O4. Finally, it will be passed through softmax function. Softmax function is another activation function. And what you are going to get in the softmax? You are going to get the y hat. So you are going to get y hat. So y hat, you are going to what is this softmax? So this y hat is dependent on O4. Y hat is also dependent on W double dash. That is the weights assigned to. So that is, it is dependent on both. Correct? So now let us say, now if you want to update the weight, what you have to do? This is whatever so far what we have discussed is forward propagation. What is this? Forward propagation in RNN. But not only forward propagation, in forward propagation there is no updation of weights. Updation of weights will happen only in backward propagation. So I think it is updation of weights happens in backward propagation. So now you see here, if you go for backward propagation, backward propagation, right? So if you go for backward propagation, what happens? So I told you, if you go back, so if you go here, so here y hat is there. So y hat is dependent on O4 and W4. So what is this? Already you know, this loss is equal to y minus y hat. What is y hat? Y hat is dependent on O4. Also it is dependent on W double dash. In our architecture, whatever we are discussing now. So as a result, so why we have to calculate y hat? Why will we have to? No problem. I'll connect with my data. These things should not. Okay. Yes. Okay. I think the screen is visible, right? Again. Please answer. Surabhi, Lohit.
Visible, sir.
Visible, huh?
Sir.
Yeah, okay. So here, see what I was telling. So y hat we have to calculate. What is y hat? That is the predicted output. Y hat is the predicted output. So y is the actual output. Already you know the output. And what is our aim? I want to find out the loss, and I want to reduce the loss. So what I have to do? I have to this loss is dependent with respect to y hat, right? So similarly, also this loss is also dependent on the weights, W dash, right? So if you want to update the weights, so how I can do? Dou L by dou y dash into dou means y dash is predicted output. This is also dependent on dou W dash. Correct or not? You can write like this or not? Right? So what is this? Our loss. I'm differentiating the loss with respect to predicted output, because it is dependent on predicted output, right? No, it is there. Yeah. So it is there. So dou L by dou y dash. Similarly, this output loss is dependent on output. Predicted output is dependent on weight, right? So this is means if you want to update. So what is this? If you go back here, first weight what you have to update. You have to go back. See from the output. So this is the output. From here you have to go back. From here you have to go back. So from where you have to go back? Here you have to go back. Hello. Yeah, please call me after. So see, this is the output. So this is the output. Back propagation has to happen from here. So first weight, this weight only I have to update. W double dash is only I have to update first. So what I have to do here? So look here. So I have to update W double dash. So right. So I can write it like this. So W double means world weight is equal to world weight minus differentiation of loss with respect to this is how we are going to update the normal the procedure. This is the normal procedure, right? So you are going to update this weight, right? So this is how I am updating. So when I am going to differentiate the loss with respect to weight, and I am going to deduct that with the older weights. Older weights, for example, are at 0.9. So I am going to differentiate the loss with respect to the 0.9. So you get some value. Then you update this W. So similarly, that is first stage. So now what you want to do? You want to update. So after the W, see after W double dash, what is the other weight? You have W. What is the another weight? You have W1. So both the weights if you want to update. So how I can say? So if you want to update this, what is that? If you want to update that, so for example, I will take it like this. Here. So here, if I want to update like that, so now what I am going to do? I am going to say like this. Loss with respect to y hat, loss with respect to y hat. Similarly, this y hat with respect to what I am updating? O4. What is this? Just observe. O4 with respect to means I am updating. I am calculating with respect to O4 now. Huh? So O4 is dependent on this weight W. So as a result, you see here what happens. O4 is dependent on W. Y hat is also dependent on Y hat is also dependent on W. Right? It's also dependent on.
For that, y hat become a W O for
What?
for this transaction. Loss is depends on y hat, okay?
Y hat, yeah.
But O4
Yeah.
is dependent on y hat is dependent on O4. O4 is dependent on W.
W. That is what I am trying to say.
So if you open the graph, based on the last transaction you do, if we are now if you want W1 or O3, okay?
That also again it will increase.
But for that we have to O4 dependence on the W and X4 also. No? X4 is an input.
X4, see, X4 is a input we are giving, it's a value. This is also.
For back propagation it will not.
No, we will see what we are saying. Input will be there. Input you are going to
only identify the
weights only we are going to change. Inputs will be there, but it will come. It is you can't do anything on the input. Input will come by default. It will come. By default, inputs will come. You don't know. You based on the data set, whatever it is there, that will come. Only you will play with weights and also you will play with the loss function. So look at this. So one more term got increased. So what is this? This is for updation of W. This is for updation of W. So like this, if you go on, so this is a chain rule. So it will these terms gets added. If you go backward, what happens? So like this, each updation of each weights it gets added based on the differentiation chain rule in RNN.
So what are the layers we can
See, more number of layers, more complex the network, more time it will take, and there are it might
back propagations it will go with the same layers. No?
same layers.
It will go with the 10 layers.
Sequential only it has to go for back propagation also, forward propagation also it has to go sequentially, layer after the other, layer after the other. This mathematical equation will become bigger. Mathematical equation will become bigger. So that is about what is that? So this is how the basic architecture of RNN, how it is going to work. So now what is that? So this I will start. Yeah.
If we go with the sequential, okay?